So now we're going to cover the inscribed angles for legit inside the circle rather than just on the circle. If the inscribed angle is inside the circle like this, now realize that this could still have one line that comes out. That's fine. If it's a secant right here instead of a chord, that's not going to change how you do this problem. Okay? What you need to know is this is the central angle here. And of course, we all know this box means that that's 90 degrees. But we know since it's a central angle, that means that this arc right here also measures 90 degrees. But like we said in our previous video, this inscribed angle is going to be 1/2 of this arc. So this inscribed angle is going to be equal to 90 over 2, which is 45 degrees. And I do need to see this on your paper. I need to see where you're getting that 45 degrees, at least for these first couple assignments, okay? Over here, this problem says, any inscribed angle that opens up to a diameter equals 90 degrees. In blue, outline an inscribed angle that equals 90 degrees. So the only diameter we have showing here is this one right here. I'm going to go ahead and highlight it, because this is the only line that's going through the center. Now, RT does go across the circle, but since it's not going through the center, it's not a diameter. US is going through the center, which means that either direction, the arc is 180 degrees. So any inscribed angle that has its endpoints at U and S is going to also be a right angle because it's half of the arc that it intersects. So here at UTS is a right angle. So we will say measure of angle UTS equals 90 degrees. You could have called that angle STU just as easily. That would have been fine. Okay. Now it says in red, outline 2 inscribed angles that open up to the same arc and name them in the space to the right. I'm going to actually do it in the space below, but I think you'll get it. All right. There are no central angles pictured in circle Q. So looking at this, to find 2 inscribed angles that open to the same arc, I usually start at the arcs. So if I'm looking at this arc RS, you can see that 2 lines meet at R and 3 lines meet at S. But when I follow them, RTS is indeed inscribed. But this one here, the other line that goes to both of them, is not. So that is not an arc that has 2 inscribed angles attached to it. If I look at this arc here, RU, again, 2 lines are coming in at R, 2 lines are coming in at U. If I look to this side, RSU is one of them, and RTU is also. So these are the ones that we're looking at. These are the ones that we're going to highlight in red. So angle R, try again. Angle RSU and angle RTU. Both open up to that same arc, RU. Now, what you may have noticed, and I'm going to do this in pink just so that you can see it more clearly, this arc ST also has 2 inscribed angles opening to it. And I'll just put it on the inside here so you can see it. Angle TRS and angle PUS, both open to arc ST. So there's a couple different ways we could get that one in there. Okay. All right. So let's do some examples. This is an angle that's outside the circle. So the formula for that is going to be the larger arc minus the smaller arc divided by 2 equals x. But you notice we don't have a measurement right here. What we do have is we have this arc is 33. We have this arc is 62. And we have this is a diameter, which means if I add all 3 of these arcs, I get 180. So for me, I think the easiest thing for me to do is to add 62 plus 33. That gives me the total of these 2 arcs. Then I'm going to take this 95. I'm going to subtract it from 180. And 85 is the measurement of this arc right here. Now I can carry on with my formula. So I'll have x equals 85 minus 33 divided by 2. So 5 minus 3 is 2, 8 minus 3 is 5, divided by 2 is in there 2 times 6 degrees. And that's my final answer. In order to get full credit on this problem, I do need to see either you're taking 180 minus 62 and that answer minus 33, or you're adding these two together and subtracting from 180 so that you have the numbers that you need to plug into this equation. And then you box the answer. There you have it. Okay, so the next example, this is another example of the exact same thing. Notice how different they look. But both of them are dealing with an angle outside the circle. The difference is this one has tangents. There's still an outer arc and an inner arc. So this is my outside arc right here. And my inside arc measures 130. So the first thing I need to do is I need to take 360 minus 130 to get the measure of this arc. So 230 degrees is the measure of this arc right here. Now I can plug that into the equation. This is my angle, so I'll have 2x plus 50 equals 230 minus 130 divided by 2. Well, 230 minus 130 is just 100. And 100 divided by 2 is just 50. Now when I subtract 50 to the other side, look at the surprise in store for me. If 2x equals 0 and I divide 2 to the other side, what's x going to equal? If you guessed 0, you are absolutely right. On this problem, I need to see that you've subtracted 130 from 360 to get that arc. I need to see that you've set the equation up like this, and then I need to see the proper answer boxed. I don't have to see this math in here at any certain level. I want to see your work, but I'm not going to dictate how you show that work. Just know that you need to show it. Okay, that'll be enough for this clip. I'll make another clip for the next section.